Hello everybody, welcome to this session about fossil-free steel. My name is Sandberg. I work within the purchasing department for Volvo construction equipment, responsible for raw material, cut parts and welded components for different sites in Europe.
Okay, my name is Andersson. I'm from technology department and I'm working with welded structures, casted components and so on for articulated haulers and for wheel loaders. So very welcome.
We will now guide you in our work with fossil-free steel. But when talking about fossil-free steel, then we would like to put it in the context as a part of the sustainability transformation within Volvo Group. First, a short introduction of Volvo Group. Main business area for Volvo Group is the truck division. Then we also have construction equipment, Volvo C, where Marcus and me belongs. We are the manufacturer of yellow machines like excavators, wheel loaders and haulers. We also have divisions for buses and Penta as a part of the Volvo Group.
Volvo have 3 core values. It's safety, quality and environment. The sustainability part, the environment, is right now the highest priority and it's where we spend our money and effort right now. We have decided to be a 100% fossil-free company and to reach net zero value chain when it comes to emissions. We are fully committed to the Paris Agreement and our objective is approved by the Science-Based Target Organization. 2040 we plan to ship only sustainable products. The most important and urgent step is for us is to address the emissions from the user phase of our trucks and machines. It's about electrification. We think battery electric will cover most of the needs, but we are also looking into alternative technologies like fuel cell electric vehicles, but also using hydrogen in a combustion engine. We think that combustion engines still needs to be around. We think that alternative fuels like biodiesel will have a place for the most heaviest machines in remote areas. 2040 we plan to ship sustainable products when it comes to emissions and raw material. Some of our products we have already electrified, like this small excavator. There we saw when we did the life cycle analysis, we saw that emissions from fuels, of course, reduced very much. And by that, the raw material is growing in importance. On a fully electric excavator, the raw material now stands for 66% of the carbon footprint. And then in a similar way, if you look on an electric truck, on a conventional truck, the raw material is just 2% of the emissions. But when we built an electric truck, the raw material is up to 70% of the carbon emissions. So it will be a large focus on raw material in the future on electrical trucks and machines. And when it comes to raw material, our machines and trucks is basically made of steel, so that is the most important raw material to address. And we'll talk a little bit more about the problem we have with the steel.
Talking about the global carbon footprint, then it's important to have in mind the major contribution for carbon steel emissions, and that it comes from steel production. In total, it's approximately 7 to 8%, and process-wise, most of those emissions comes when transforming iron ore into iron in the blast furnace process. It's very obvious that contribution from steel industry is needed to reach overall global environmental targets, and also for Volvo to reach our commitments. Then especially since what you mentioned, Marcus, about steel being the backbone of our products. Steel is currently the most recycled material, and steel can be produced as a recycled product coming from steel scrap, or it can come from iron or in a blast furnace process, then like virgin steel production. Carbon emissions from scrap-based steel production is way lower than the virgin steel. So it's approximately 1/3 if we compare those two processes. Then of course a question: why don't we go only for scrap-based steel? And then we need to look into availability versus the demand. And then as we can see in the picture to the left side here, steel usage is increasing over time, and even if recycling of steel will increase even further, scrap-based steel production will, just as it is right now, not cover the global steel needs in the future either. So as stated here, scrap-based steel production can't provide full sustainability solution. It needs to be solved in the virgin steel production. If looking at conventional steel production, then most carbon emission appears during the blast furnace process, like the one visualized on the left side. In this blast furnace process, then iron ore is reduced and becomes iron. Here we typically talk about 2,500 kilo in carbon emissions for 1,000 kilo of steel. If we look at the right side, then it describes this hybrid process developed by in a joint venture between SSAB, Vattenfall, and LKAB. Here, hydrogen is used when transforming iron ore into iron, and product will be sponge iron, as stated here. The rest product from this process will be hydrogen and water, which is way more sustainable compared with carbon emission. And this technology step will contribute to reduce carbon footprint for steelmaking a lot. In the market, there exist similar initiatives, but as far as we know, SSAB is the most advanced. We also have in Sweden, we can mention about this H2 Green Steel initiative. They have a similar time plan as SSAB. If you would like to know more about this hybrid process, then we would like you to go to SSAB homepage. There will you find way more details about this. Beginning 2021, Volvo Group entered a partnership with SSAB, and this was then connected to fossil-free steel. And in coming minutes, we will present at least a portion of the outcome from this partnership.
So one part of this partnership with SSAB was to share the verification of the new fossil-free steel. So together with SSAB, we made several different verification activities on this new steel. and we did a lot of different tests. We did chemical composition evaluation. We have a look on the microstructure, like non-metallic inclusions, austenite, grain size, and looking on the base microstructure. We did also a mechanical test like tensile testing, impact test like Sharpie test, and we evaluated the hardness and so on. And we evaluated the process properties, you can say, in operation, such as thermal cutting, bending, rule forming, welding, machining, and surface evaluations. Okay, so what we found out was that steel properties were not affected when we compared to conventional steel.
One reason for this not impacting the steel properties is that when we look into this hybrid process, then we primarily talk about upstream activities like making the iron. A lot of the properties visible for us are typically coming from downstream activities like thermomechanical processes for the steel or rolling of the steel.
Yeah, so it's the iron making process that is new. The steel making process is just as normal, and we can show it by verifying the properties. So after doing these tests on the material and verifying the properties, we were confident to start building the first demonstration vehicles together with SSAB. So this is the world's first vehicle ever built from fossil-free steel. So this vehicle here, we have it internal Volvo. So it is used for evaluation and verifying the steel properties and so on. So that has been done, and building confidence from this machine, we were also ready to take the next step in June this year. And we started to approach customers with this new fossil-free steel. So here in an event in Stockholm, we handed over the first customer vehicle to NCC. You can see the CEO here with a key made of fossil-free steel, of course. So we are now approaching customers with this new steel. And lately we have also taken an additional step.
Yeah, a few weeks back we could proudly present another fossil-free steel milestone. The fossil-free steel from SSAB is now introduced also for a portion of frame rails for the full electric range of trucks. Due to limitations in steel availability, it will not cover all deliveries, but at least a portion of the deliveries. Currently, we are working on a way forward. It's always good to be able to show some showcase and partly implemented for limited serial production, but the big steps will come slightly later. So we are working on a way forward on how to implement fossil-free steel. Or need to mention it when we mention about fossil-free steel, we don't really think that it exists. In reality, it's more like near zero emission flat steel, like you stated here. There will always be some carbon footprint coming from steel production. But we have a plan to implement it for all Volvo products, and this strategy and how quick we can advance with the implementation is, as mentioned, dependent on availability of fossil-free steel. But hopefully this development by SSA and other mills will make it possible to create an even more aggressive implementation plan versus what we show in this schematic draft. In this draft we can see different phases. If we look at phase 1, we can see in the left down corner, this is what we have presented today about some demonstration vehicles and also some limited serial production. Phase 2 will be connected to readiness from SSAB and some other mills, where we plan to take as big step as possible and implement fossil-free steel. And here we talk about quite near future. We talk about 2026, 2027. And then we will see a gradual implementation, and readiness is planned to be 2040. But for sure, our aim is to stretch this and to go full implementation as soon as possible.
Okay, so if we should do some kind of summary here, Volvo have an ambition sustainability journey ahead. We are aiming for 2040. It's the year when we will only ship sustainable products. Electrification is the most important, but of course raw material is important as well. And here comes fossil-free steel into the picture. Yes.
So thank you for listening. If you have further questions, we will have this QA session, and hopefully we're able to answer your questions. Thank you all.
Thank you.